Welcome back to another episode of Program That Part, and today we're going to program the part that I made for machine side tool holder that I previously machined a couple videos ago. This must have been a while back, but card here to that video. So this part holds all of the Tormach TTS tool holders basically upside down, so I guess you'd call it the shank fits down inside these holes here. And this is to be machined out of maybe some UHMW or some high density polyethylene, so we can pretty much bump the speeds and feeds up a little bit more than usual. So we're going to rough cut this stock out with the bandsaw and then mill this side and this side to length before we machine out everything else, and that'll just be to hold it in the vise. So that'll be already ready to go. The stock size of this piece will be 12 3/4 by 3 by 1.02362 whatever, and that's sort of just what I got roughly with the measurement from the calipers, and I took it out pretty far. Actually, I don't even know why it is out that far, but anyway, no big deal. So there is the stock piece, and you can see we have a little bit to face off here. So we're going to start off with the facing operation, and I'm going to do this with the shear hog 3/4 inch end mill, single flute end mill. So I'm going to run it at 4,500 RPM, 60 inches a minute, and we are going to select this chain, which is basically this top height of the part. Here is all of our heights and everything. Not a big deal here. Pretty generic, and just pretty generic here as well. I mean, nothing really to, you just select that and I just really pretty much go. Except with the step over here, I have just over half an inch step over, and that's just I could probably get more than that, but it's just easier to do this way, and it looks a little bit better in my opinion. Next up, we are going to drill these holes here. These are through holes, and we are going to be using a 1/4 inch drill, 5,000 RPM, 10 inches a minute, and we have a chip breaking cycle picked here, and we're just going about a 1/16 of an inch pecking depth. We could have gone a lot more than that, but that's alright. And then after we drill those holes, we're going to contour out these counter bores here. For that, we're going to use a 1/4 inch flat end mill going 5,500 RPM at 65 inches a minute, so we can really crank on this one now. So I selected all three of these counter bore contours, got my generic height set up, and I'm doing 6 roughing passes at 10,000ths of an inch, and then my finishing pass will also be 10,000ths of an inch at 65 inches a minute. And I will select these pre-drill points, so that's basically telling the tool that, oh, I can plunge down in here and then contour out, and then everything else is basically just left the same. And then up next is to clean up these sides here, and these will be cut to length, well, very roughly cut to length with the bandsaw. And I'm just going to come in here with a 1/4 inch flat end mill, 6,000 RPM at 40 inches a minute, and I'm going to do multiple depths here. And once again, I selected these contours here. It wants to select the whole thing like that when you select the bottom, but when you select it and then click it again, open contour, and hit the plus sign, that will allow you just that piece right there. So that's how I ended up selecting these two contours on both sides here. And my generic heights are set up. I'm actually going 5,000ths below the bottom of this actually. So I selected this bottom face and selected to go 5,000ths below the bottom just to make sure I get everything on this side here. And here is my multiple depths. I'm going 0.4 inches deep each pass. So you can see that here in a second after I get out of here. And everything's left the same on this tab as well. So 0.4 inches deep, and the last one's not as deep, but you can see that is just slightly below. Almost can't even tell, but it is slightly below the bottom of the part here. Do this side, then wrap it over and do this side as well. And now to do these 5 big bores here, and that's where the tools will fit. And I probably could have used a big drill to drill these out first, and that would have been a lot quicker. But we ended up going with an adaptive 6,000 RPM, 40 inches a minute with a 1/4 inch flat end mill, and I selected those 5 chains there at the bottom. Everything's pretty much generic here. The bottom height is the selected contours, and multiple depths again. I used 0.4 inches, and I'm leaving 0.01 inches stock to leave radially, so that's on the sides, and 0 on the axial, and there's nothing there axially, so it doesn't matter anyway. And my optimal load on this one will be 70,000ths of an inch. And pretty much everything up here is the same. With my ramping, I'm using helical at 3 degrees. Usually that's around 2 degrees, but since I'm machining UHMW, I can be a little bit more aggressive, so I went 3 degrees, and my helical ramp diameter is 0.2375. I think that's pretty default for this tool, and that'll give us the tool path we want. See, it'll helical down, and then once it gets 0.4 inches deep, then it'll clear out everything, then it'll helical down another 0.4 inches, clear out everything, and then finally to the bottom it'll clear out again. And then with the contour, I'm going to contour these out, just clean them up real nice from the adaptive. 6,000 RPM with a 1/4 inch flat end mill, 40 inches a minute. We selected those 5 chains again, and we left everything here on the heights tab, and we went 0.4 inches deep each pass this time as well, and that pretty much gave us exactly what we want. Everything left here, and there's the tool path. So 0.4 inches, finish everything up, and it'll do that 2 more times in each bore. And then we're going to put a hefty chamfer on each one of these 5 holes here with our 90-degree spot drill, and that's 1/4 inch spot drill, 6,000 RPM at 40 inches a minute. We selected each one of these 5 holes here, and pretty much everything is generic on this tab as well. And the chamfer width is 0.1 inches, and that's pretty hefty for this. And then everything else is the same pretty much. And that'll give us this tool path here. So that'll be the tip of the tool, that blue line right there. And then in the next tool path, we will go ahead and put a chamfer all the way around everything, just to make it look really nice and make sure there's no real sharp edges. Once again with the spot drill, 6,000 RPM, 40 inches a minute. Selected this whole outside chain, left the heights tab alone, went over here, and I'm using a 50,000ths of an inch chamfer width, and chamfer tip offset is 0.04 inches, and chamfer clearance is 25,000ths of an inch, and everything on this tab is left alone. And that gives us what we want on this one. And we'll go ahead and do a simulation because the chamfers don't really show on this, and I hate modeling in chamfers when I know I'm going to machine one in there because it's just easier this way. So select that, simulate. I will delete the component, turn the stock on, toolpath off, turn the tool off, and this is what we're left with. So you can see the real hefty chamfer there, but it ended up turning out pretty good. And they still work. I have 2 of them now on the side of my machine, and they work great. So if you guys have any questions, leave them down in the comment section, and I will be sure to get to them. Thanks for watching.